Whenever you look up, the sky is putting on this incredible show. You've got the deepest blues, fiery sunsets, that perfect arc of a rainbow. It's a masterpiece happening above our heads every single day. So today, we're going to decode that show. We're breaking down the science behind the sky's most amazing tricks of the light. And let's just dive right in with this stunner. Take a look at this. This is a real photo from Greenland. You've got these crazy arcs, circles, bright spots of light, all happening at once. This is not a camera trick. So the question is, how does our atmosphere cook up something like this? Well, to figure it out, we've got to start with the basics.
And there's really no better place to start than the question we've all asked since we were kids. Why is the sky blue? Answering this one is our first step on a journey from the everyday to the absolutely extraordinary.
Okay, so first things first, we need to talk about sunlight itself. To us, it just looks white, maybe kind of yellowish. But in reality, it's the whole package. It's got all the colors of the spectrum, red, orange, yellow, all the way to violet, all bundled up and traveling together. Now, each of those colors travels as a wave, but here's the catch. They're not all the same size. Just imagine blue light as these short, kind of choppy, high-energy waves. Red light, on the other hand, is made of these long, lazy, stretched-out waves. And that single difference, well, it's the key to everything. Turns out, there's a name for this whole process: Rayleigh scattering. See, our atmosphere is packed with these teeny tiny gas molecules, way smaller than a wavelength of light. And they are the perfect size to get in the way of those short, choppy blue light waves and just ping them off in every single direction. Up, down, sideways, all over the place. So when you're standing outside on a clear day and you look up, the light you're seeing isn't coming straight from the sun to your eye. Nope. You are seeing blue light that has been bounced around by trillions of air molecules all across the sky. And that scattered light is what fills the whole dome above us with that brilliant blue color. Okay, that makes perfect sense for the middle of the day. But hang on a second. What about sunsets? If our air is so good at scattering away all the blue light, where in the world do those incredible reds and oranges come from? Well, the answer is it's the exact same process, just with a little twist. It all comes down to the journey the light takes. When the sun is high overhead, its light takes a pretty short trip through the atmosphere to get to you. But as the sun sinks to the horizon, its light has to travel through way, way more of that atmosphere to reach your eyes. And on that really long trip, pretty much all of that short, choppy blue light gets scattered away. It's bounced right out of the direct path before it ever gets to you. The only colors that really survive that marathon journey are those long, lazy red and orange waves. They're tough enough to make it through. And this is the gorgeous result. What you're seeing in a sunset is literally the sunlight that survived the journey. So a blue sky and a red sunset aren't opposites. They're two sides of the very same coin. All right, so we've covered how light plays with air, but let's add a new player to the game: tiny little droplets of water. This is where things get really colorful. The secret to a rainbow is that every single little raindrop is a perfect tiny prism floating in the air. It can catch that white sunlight, bend it, split it apart, and shoot it back out as a full spectrum of color. And it all happens in this little three-step dance. First, as light enters the raindrop, it bends. That's called refraction, and the colors start to separate. Second, the light bounces, or reflects, off the inside back wall of the drop. And third, as it leaves, it bends again, spreading those colors out even more for us to see. And here's the real magic. That light doesn't just come out at any old angle. For a primary rainbow, it always exits at a very precise 42-degree angle relative to the sunlight coming in. That number, 42 degrees, is what creates the perfect arc we see. Now here's something that might just blow your mind. Because that light has to travel from a specific raindrop at that perfect 42-degree angle directly to your eye, the rainbow you see is made from a totally different set of raindrops than the one the person standing right next to you is seeing. Your rainbow is yours and yours alone. But every now and then, if you're really lucky, you get a bonus feature: a second, fainter rainbow right above the first one. But have you ever noticed that its colors are flipped? Yeah, there's a really simple reason for that. It's all about a bonus bounce. For that second rainbow, the light actually reflects twice inside the raindrop before it comes out. That second bounce completely flips the beam of light around, reversing the order of the colors. So you end up with violet on top and red on the bottom. Pretty cool, right? Okay, we've covered air and we've covered liquid water. But the atmosphere has one more trick up its sleeve. Let's introduce our final ingredient to the mix: frozen water, in the form of millions of tiny ice crystals way up high. What you're looking at here are called sundogs, and you can basically think of them as winter's version of a rainbow. They aren't made by round raindrops. Instead, sunlight is passing through millions of tiny, flat, six-sided ice crystals. And that perfect hexagonal shape is what creates these amazing patterns. So let's put them head to head. When you're out there looking, what's the difference? Well, rainbows come from raindrops, and you always see them with the sun at your back. You're looking away from the sun. But sundogs, they come from ice crystals, and you'll find them right next to the sun, like a pair of bright companions on either side. Okay, that was a lot of science, right? But the goal here isn't just to understand all this, it's to get you to go out and see it for yourself. So let's turn you into an active skywatcher with a quick little checklist. Here's your cheat sheet. For those fiery sunsets, you're looking at the golden hour, the first and last hour of sunlight. For rainbows, remember the golden rule: sun at your back, rain in front of you. For sundogs, you want to look on cold days when you see those really thin, wispy clouds high up. And hey, anytime you see a rainbow, always look a little higher for that fainter, flipped bonus rainbow. So you see, the sky is not just some empty space. It's a stage, and light, air, water, and ice are the performers putting on a new show every single day. We've just handed you the program. Now the only question is, what are you going to go see first?